Stop this. Okay, so change the right to a base 5, so I can cancel out the bases. So this would be 5 to the third. So x minus 4 equals 3, therefore x is 7, right? And we did ones like this in Unit 7. You guys practiced one yesterday in one of those elevation maths. What if I said this? Now we're in a bit of trouble. Why?
You can't make that a base of 5.
Right. Can't make that a number with base 5 or into a power with base 5. But we need to know how to solve these. This is where logs come in. Okay? So if I go back here, I'm just going to go to this example first. How do I tackle something like this? Because I know the answer is going to be between 2 and 3. Because 5 squared is 25, too low. 5 to the third is 125, too big. But the question is, where is it between? Well, to do this, what we do is we log both sides. And when I say log both sides, notice I didn't specify a base. What base do I mean then? 10. Because we're going to have to use a calculator for these questions. Because we can't do it, because we can't write 40 as a power with base 5. Okay? So now I've got to get x by itself. But right now, x is in an exponent, in a log. How do I get it out of here? Yeah, I can use one of my log laws to put it in front. So log 5 to the x is the same as x times log 5. Remember, we're solving an equation here. We're trying to get x by itself. So x times log 5, how do I get rid of the times log 5? Divide log 5. So now you have to use your calculator. And let's go 3 decimal places, because that's usually what we're asked for. So I would suggest you know how to do it. You know how to use your calculator for this. Okay. And you should get an answer of 2.292. Makes sense, because we said the answer should be between 2 and 3. Okay. 5 squared is 25, that's too low. So 2 is too low, 3 is too big. So that's how we solve exponential equations that we can't write the bases the same. We have to do logs. So for example, b. Well, I can't make the bases the same, 4 and 3. So I'm going to have to log both sides. That's the first thing I do. Now notice I've got x's in both exponents. I've got to bring, remember, the whole goal is to get x by itself. That's what solving means. So I've got to bring this in front, and I've got to bring this whole thing in front. So I get x log 4 equals, and remember this exponent has to stay together, so I have to use parentheses, 2x minus 1 times log 3. Well, I can multiply this out, multiply this through. So x log 4 equals, and then I've got to multiply these two. 2x log 3 minus log 3. What would you do now? Let's say you kind of gave a gesture there. No, you sure? Because it looked like the correct gesture. Okay, now you gave a completely different gesture. No?
You put them all you want.
Put all of what? All of them?
Like the bias, well, like there used to that. Make it together. I don't remember.
Remember, I want x by itself.
Even one without.
Get the logs with the x's in them together. Yes. So I need to bring this over here by subtracting 2x log 3. Subtracting 2x log 3. So you're going to get x log 4, subtract 2x log 3 equals, and what remains on the right-hand side after we brought that over? Negative log 3. This next step you're really going to have to think of. We got the x's together on one side, but somehow I have to make this look like x equals at the end. Any ideas? This is a challenging question. How we can somehow, like I've got the x's in 2 logs. Excellent. Factor the x's out, do GCF. So take x out. If I divide x out of this, I'm left with log 4. If I divide x out of this, I'm left with minus 2 log 3. So it's GCF factoring. Why did I need to do that? Because now there's only one step to get x by itself. Divide both sides by this expression. Those will cancel. So therefore, to find x, I'm going to have to do this whole thing on my calculator. It is not as easy as it seems. Okay? Because you have to use parentheses correctly. Remember, I have to do this first and then do the division. So what I do on my calculator is I'm going to do negative log, and then it opens up a set of parentheses for me. I hit 3 and close that set. Then I'm going to divide, and I've got to keep this in parentheses. So I got to open a set of parentheses. Log 4, close the 4 parentheses, minus 2 log 3, close the 3 parentheses, and then close these parentheses. If you don't use the parentheses correctly on your calculator, you may get an incorrect answer. What you get? 1.355, so you did it right. Excellent. Good job.
I did it wrong. I just said it there.
Yes.
Not no, make like will not be a good way to go. Like not that.
No, but to know that something went wrong.
Yeah.
Yeah, absolutely. Yeah, you got to be, I know, when you do more complex log calculations, you got to really be careful with the parentheses. Okay, and different calculators are different. Okay, so actually what I'll do is I'll just fill this in because we actually showed the steps here. So we take the common log of both sides. Right, that's the base 10. Then we have to use, log. No, never mind. I already did do the common. Simplify. Sorry, I forgot what I was saying. You got to bring, because the variable in these type of equations, the variables are always going to be in the exponents. So you always got to use that log law to pull the variable out of the exponent and then in front of the log. Okay, so take a log of both sides, pull these in front, and then use algebra to solve. Okay. Sometimes, like in example B, we get an equation that has more than one term containing a variable. We have to get them to one side and then factor out. And I'll even be more specific, GCF factor out. It'll always be a GCF. Okay. Okay, so let's just look at a few more examples. First step. Log both sides. Second step. Pull the exponents in front of the logs. Pull the x's in front of the logs. Now we've got to do algebra to get x by itself. We're going to see x more than once, so we're going to have to do some factoring. So first of all, multiply these two by log 7. So we get x log 7 minus 5 log 7. And then we have to multiply x and 2 by log 3, so we get x log 3 plus 2 log 3. Now we got to swing a couple of things. I'm going to take this over to this side by subtracting x log 3. At the same time, I'm going to take this over to this side by adding 5 log 7. So I'm going to get the x terms together on one side and the ones without the x's on the other side of the equation. So the left side will now look like, well, I've already got x log 7 here. I brought this over by subtraction. That will equal, I've already got 2 log 3 over here. And I brought this over by addition. Okay. Factor out the x, GCF it out. And then we've got to divide both sides by log 7 minus log 3. Well, now we're ready to use our calculator. Okay. So give it a shot. Because like I said, you need to know how to do this. So these ones are you're gonna have to put those in parentheses and then divide and then those in parentheses. So 2 log 3 plus 5 log 7. Who thinks I got it?
14, 14.
Emily? Good. Need one off.
Like, I know this version is seven. And like, I got 7. Well, because I was this, then I got this.
You may get a communication error for that. It's not wrong, but you might get a communication error for rounding too early. And actually, it's probably likely that you would. That's on the potential. Okay, this one, a little bit different. What's so different about this one? One of these things is not like the others. You guys, be quiet, please. Yeah, it's got that 2 in front. Okay. Well, it'll still do it the same way. On both sides. That's it. If that was a sneeze and not a laugh, press laugh. And it sounded like it. Now, left side, or sorry, the right side, that seems pretty obvious how to switch it. But what about this here? You cannot, because this 2 is here, you cannot pull this in front. Okay? Multiply? You can't multiply a number by a power like that. That's not 6 to the x. But thinking multiplying is getting along the right track. Could I somehow separate these? Divide? How can I separate these out? Exactly. You have to use another log law to separate those from each other. Now I can pull this in front and make it x. Okay? So when you see this, you're going to have to separate it into 2 logs being added. Because when they're multiplied, you separate it out, it becomes addition. So I get log 2 plus x log 3 equals x log 5 minus log 5. Well, I've got some work to do. I've got to swing this over to this side by subtracting x log 5. And I've got to swing the log 2 over to this side by subtracting log 2. So when I do that, I'm going to get x. I've already got x log 3 over here. And this comes over and becomes minus. I've already got negative log 5 over here. This comes over and becomes minus. So I've got the terms, the log terms with the x's on one side, without the x's on the other side. GCF that x out. Like so. And then divide both sides by this. Now we're ready to use our calculator. This one, I'll just give it to you. This one works out to 4.508. Okay. We've got a couple more to do, and you may be thinking, boy, that's a lot of work. Well, if you think, it just might not be. If you just stop and look at the question, it just might not, it might be easier. Yeah. Yeah, change them to base 2. I don't have to log both sides yet. That's much easier. If you did log both sides and you went through the whole thing, it would still work. Okay. But this wouldn't be, this would be in the non-calculator. So 2 to the 3x minus 1. Well, when I raise one power to another, I multiply the exponents. So I am left with 3x minus 1 equals 2x. Take the 2x over here, it becomes x. Take the minus 1 over here, it becomes plus 1. That's my answer. That's it. X is plus 1. Okay, so remember, take a look first. Always look and see, hey, can I do it without logging both sides? How about F? Can you log both sides? Well, you can obviously log both sides, but can I write them in the same base? Somebody said it. You don't have to log both sides. You said log. I don't have to log. I don't have to do any logs here. Yeah. The number 1 is the same as 4 to the 0. Cross those out. X plus 3 equals 0. X equals negative 3. Okay. So you don't have to write this down, but just to sort of summarize the last couple of lessons, and from unit 7, you should know how to do 2 types of exponential equations and two types of log equations. If I give you something like this, okay? These are two different types of exponential equations. This base is the same. You can make bases the same and go from there. Here, you can't make bases the same, log both sides and go from there. Right? There's two types of log equations. I'm writing very simple ones. There's a log equal a number. That's when you got to go to exponential form. So you got to go 5 to the 2 is equal to x, and then solve from there. X is 25. Okay, that's the only way you can solve those ones. When there's a log on both sides, very similar to this, as long as the bases are the same, I can cross out the bases, and x equals 2. But remember, with the log ones, state restrictions. Make sure you state restrictions. You don't have to state any restrictions when it's exponent. Okay. So there's just two things remaining. One is to actually look at some types of problems that involve logs. Okay. And then we are going to look at a special number, like pi, except it's a different number, and we give it a different letter. But we'll talk about that starting tomorrow. So for next